Myself, buoyancy Jadeja.
Myself, Hadiya, and today we are going to discuss about
metacentric height experiment. Metacentric is usually considered as a measurement of stability of a floating body. Hence, it is a very important concept while designing ships.
Let us consider a body floating on water. As we know, body floats on water because the mass density is lower than mass density of the fluid. Wood, plastic and ice cubes are examples
wherein density of floating bodies are lower than density of fluid. A body also floats on water when the weight of fluid displaced by immersed body is equals to the weight of body, as in the case of boats and ship, etc.
In case of ships, two types of forces act on it. First is vertical down force of gravity, which is equal to the weight of the body, which acts at the center of gravity of body. G. Another force which acts on the ship is buoyant force, which acts due to force exerted by fluid on the ship. Buoyant force F is equal to the weight of the water displaced by an immersed body. The buoyant force passes from the center of the displaced volume of water, which is also called center of buoyancy B.
Now, for a ship to be equilibrium, buoyant force must be equal to weight of a body, and also point of center of gravity and center of buoyancy should lie on the same vertical line. When the ship tilts in the right direction, the volume displaced in the right direction is larger as compared to the left direction. Due to this, the center of buoyancy shifts in the right direction from point B to B.
Due to large volume of water, more force is applied, resulting in the formation of couple. The point of intersection of the vertical line through the new center of buoyancy B and the center line BG is termed as the metacenter of the body.
The distance between metacentric point and the center of gravity is known as metacentric height. We can also write metacentric height as Gm in equal to Bm minus Bg. Floating bodies possess three types of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium.
When metacenter M is above the center of gravity G, this is called a stable equilibrium. In this case, a restoring couple is formed by the buoyancy force and weight of the body, which tends to turn the body into their original position.
Now, when metacentric point is below center of gravity G, the overturning couple forms of buoyant force and weight of body, which tends to sink the body from the original position. Thus, the body is said to be unstable equilibrium.
When metacenter point EM coincides with center of gravity G, weight of the body and buoyant force becomes collinear and pass through same line of action,
due to which the body neither returns to its original position nor increases its displacement in the remain in that tilted position. Thus, this body is said to be neutral equilibrium.
This is typically used while designing shapes higher the metacentric, higher the stability.
But if metacentric height is kept too large, it will continues oscillations, resulting in discomfort to passenger. Hence, passenger ships have lower metacentric height as compared to warship and rafting boats.